we're about to start recording. There we are, we're recording. Anyway, today is the halfway point in the class. This is it. We're halfway. So isn't it exciting? You're halfway done. And you still have like multiple exams to take. That's the problem with math classes, is that you can't take tests until you've learned stuff, right? So it ends up being the back half of the class has more of the tests in it, you know? It's the nature of the beast. I can't test you on chapter 8 until we've covered chapter 8. So yeah, we're almost, well, we're just halfway today. So I think today is the halfway mark. So that's kind of exciting. A little bit, and we're almost done with chapter 8. This week we're gonna finish it. So if we look at, maybe I'll do this instead of well, I'll do this both. So today, Zoom class, yay, woohoo. I'll post the recording later. And I will remember this time, I swear. It's just, what happens is I usually leave. I go do errands, or I go walk the dogs or whatever, and I'm doing a million things and I forget, and then I don't get it posted until later today. I'm not doing it intentionally. I always keep the blue button session in reserve just in case Zoom crashes out and we need to do that. So tonight, 8-7 is due, and 4-7 is a quiz. Ha! It's a miracle. All right, so 4-7 is a quiz, and 8-7 is an actual submission. Now remember, when you're doing 8-7, don't use the what do you call them? The computer until you get to that point. It actually asks you to use the computer for like think of the last two. And then the other ones, when you're using the big table, make sure you write down, like, I use number 113 on the big table or whatever. Just put like number and then circle it, and then you're good. I mean, half the problem in those problems is finding which one on the table to use. Go ahead, Daniel. You got a question for me? I saw you unmute. Hey, guys, I turned on the other day. I tried to turn on ways for you guys to non-verbally tell me stuff, like raising hands and stuff. Do you guys see other options available to you down there? You know what I'm talking about? In your options where it had the reactions, does it have other things? Anybody see anything else? Jessica's saying no. Bummer. All right. Well, I tried to turn it on so you guys could, like, there's apparently a raise hand feature, so you can kind of like raise your hand in the, as like an icon, and then I can use that, but I'm struggling. Maybe I'll have to go back to the settings for this particular chat, and because I basically made a repeating Zoom meeting, so I might have to go back and double check things. Sorry, I was trying to give you guys more options to get me to shut up. So speaking of which, I can shut up. All right, so you've got a quiz due tonight, and you've got 8-7 due tonight. 8-7 I don't think is too difficult, but maybe you guys will have a lot of questions about it. And then 4-7 is L'Hopital's rule. And I posted the 8-9 lecture videos. They are long, just as a warning to you. 8-9 is a pretty long section. So I think there's 9 of them, 7 of them. Jeez, I can't remember. Here, I can tell because it's on the screen behind where I'm looking. It's 9 of them. So sorry about that, but it's only one section. So 9 videos you'll have to watch for Wednesday, and then ask me questions about that on Wednesday. And because on Monday of next week, you must have your webcams on. I will be watching you. Very exciting stuff. And I will post the exam. I'll probably start the session early. I'll probably start it early at like 9, say, and then that way people have a little bit more time, and then we'll go from there. So I'll post it right around 9 o'clock. You guys will be able to get in, show me your area and all that good stuff. So you'll actually probably want to get up and prepping early, so that way you can have everything ready to go. And then that'll be it. And then I'll be watching you, and then you'll take your test, and then you'll submit it right away. You'll submit it through, I think it'll probably be just a paper submission, like you do for the sample exam. I think it'll be you taking pictures with your phone and scanning it, and I'll give you, 10 minutes or whatever to submit it, or, immediately after you're done, within, 5 minutes of finishing and whatever. All right, everybody good? Got questions? troubles? Oh, I forgot to pull out my book of my book of worksheets, so I'm not going to be able to help you with worksheets until I get that out. Okay. So. Questions, troubles, questions? Anything? Oh my God. I almost knocked over a binder. Very big statistics binder that would have gone crashing to the ground. So sorry about that. All right. Anything? Okay, cool. Then we're ready to go. So if you guys are good, questions on 8.7 or 4.7, or I can answer questions on previous ones too. Oop. 8.7. I got an 8.7. And you can look over your other ones too. If you want like something from, if you don't understand something from 8.3 or 8.4 or 8.5, 8.6 that I graded, if you want my help. I think there were a couple of them that a lot of people got wrong. So feel free to look back through those while you're sitting around looking pretty, drinking your coffee, and letting me know. All right. So 8.7, 10B is what I see. 8.7. Oh, okay. So for 10B, you're going to need to find, hold on, I got to get that big table out. I got to remember where I put it. It's the integral table with all of its integration stuff. One moment while I find it. Where the heck did I put it? I can find my statistics tables, but I can't find my calculus tables. Ah, grr. Well, I'm going to have to pull it up electronically because I have no idea where it is. That's a bummer. I might have recycled it accidentally. I'll have to go check the recycling box. All right, so let me pull up the big table. Hold on. Big table. Hold on, sorry guys. Give me 1 second. 154, big table. Where are you? Full integral table. There it is. Sorry, I'm gonna have to wait for Microsoft Word to wake up and decide what it wants to do. Haha, there we go. All right, so there's that, because I know we're gonna need it, because this particular problem is all about big table. And then, let's see here. Oh, you guys did raise your hand and lower your hand. You found it, Ben. You're able to do it. Ben, you have a question? Ben raised his hand for no reason. Oh, shish kebab. There it is. I got it. Okay, we're doing. Woohoo! All right, so we're gonna have to go find something that'll fit what Amna's given us. And Amna gave us 10B on, there we go. All right, so 10B, which is 8.7. Right? Whoa. Ah, hold on. All right, so there we go. No, I see, Ben. You just wanted to see if it would work. All right, I'm going to lower your hand then. If you have a question, you can raise it, though. That'll be cool. There should be some other things. That's what they've been emailing me. Zoom's been emailing me like, we're doing blah, 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 and putting in these features. And so I don't know what features are there. All right, so 8.710b. I'm finally there. All right, so it's x squared e to the 5x dx, like this. Hold on, I'm super zoomed in again. It was for making videos. Okay, so there you go. There's my hand. Hello, hand. Okay, so let's see. I mean, me personally, I'm thinking u sub of some kind. If I make u equal to, well, I did u equal to 5x, amazingly enough. Let me try it. So I did u as 5x when I did this. And then du would be 5 dx. And then x squared would be, well, x would be u over 5. So x squared would be u over 5 squared. Hold on. So if I rewrite this as u over 5 squared e to the u, and du, oh, du is too big because it's got a 5 in there. So I'll put a du and I'll put a 1/5 like that. So that's 1 over 125 u squared e to the u du. And I think there's one that's like that. Hold on. Oh, but everybody okay with what I've done so far? Wah! Sorry, I'm having problems with something blocking me here. All right, so everybody good with those ones? So I just did a u substitution. I made u equal to 5x. This is u over 5. 5 squared is 25. And then this other 5 comes from the fact that du would be 5 dx, and I don't have a 5 in there. So I did 1/5 du is equal to dx. So that's where that 1/5 comes from. You good? All right, and then the table. All right, which I have no idea where my table is. I'm really frustrated by that. All right, so if you grab said table and you start scrolling around, as I recall, this one's on the last page, but let me double check that. Hold on, it's being very slow and annoying. Oh, really? You went to the empty page? Ha 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 ha. Wait, come back. You were right there. Ah, things involving e to the u. See it? See that? Forms involving e to the u? Okay, so by making u 5x, we're getting an e to the u form. Ah, we like it. Okay, so which one? Which one of these is going to be remotely useful to us? I think it's 112. Do you guys see 112? See that one? Right there? U to the n, e to the u. So for us, n would be 2, and I think that's the one, right? So we'll use that one. So number 112, right? N is 2, and then u is u. We'll just leave it as u for right now. So we're going to do u to the, here. So it's u to the 2, e to the u, minus 2 integral u to the 1, e to the u, du. A telemarketer is calling me. I'm going to hang up on them. Okay, so my phone started buzzing, but it's one of those Colorado numbers, which is always a bad sign. All right, so I'm using rule number 112, right? And n was equal to 2 on this one for us, right? So rule number 112, n was 2, and so we're sitting right here. And then we still have this integral of u to the 1 e to the u, which I think is actually a different one. It's right there. Look at 110. Although 110 technically is 112, but like in a simplified version. So we can use 110 for the next step. Right there. So we're going to actually use 2 forms on this one. Or you could use 112 twice, because 110 is just a special case of 112. So it's minus 2, and then I got to grab that again. What was that? All right, u minus 1. So u minus 1 e to the u. And then I'll add my plus c on at the end. Like that. And then I'll just go back and put in what u was. U was 5x. So this is 5x squared e to the 5x minus 2. And then 5x minus 1 e to the 5x plus c. Right? And then if you want, you can go, oh, that's 25x squared e to the 5x. minus, and then you can distribute this. This would be minus 10x e to the 5x plus 2 e to the 5x, which me personally, I would factor e to the 5x out of all that crap and make it 25x squared minus 10x plus 2. Although not strictly required. I mean, it didn't ask us to do that, but why not? Everything had an e to the negative 5x or e to the 5x in it. So I might as well factor it out. Oh, crap. I lost my 125, didn't I? God bless America. You guys should have said something. Shoot. I was going to lose points. 1 over 125. All of this garbage. 1 over 125. All of this. 1 over 125. All of that. Technically, after the c. The c is arbitrary, so it doesn't really make any difference. There we go. Woo. So 1 over 125, all of that. So I'll do 1 over 125 there. Sorry. See, you guys should have said something. Oh, could I use rule number 111 and skip the U sub? I don't know. Let's go check it out. Let me see what it is. Hold on. Oh, Microsoft Word, you are my nemesis. Oh yeah, sure, right? Because we had x squared e to the 5x. Yeah, that would work. I didn't even see that one. So that would totally work. That number 111 is completely set up for it, right? N would be 2 for us, and A would be 5, right? That's another one that would work. And it looks like it would give us kind of, I think it looks like the same thing. We probably would have a duplicate. We'd have to do it twice because it has that integral inside of it, and it'll be x to the 1 e to the 5x again. So yeah, totally, that would work, Shayna. Good call. See, with these ones, there's often a couple ways you can do them. Not all the time, but a lot of the time. There's more than one. So works. Use either one. You should end up in the same spot. Don't forget your 1 over 125. Oh my God. If you do the U sub. If you don't, you'll get it eventually. It'll pop up in the 111 as you're doing it. You'll get 1 over 5, and then you'll keep, cycling through. So it'll appear. Technically, if I wanted to, I could distribute the 125 into here. 25 goes into 125 1/5. That's what happens in the 111 formula, and then 10 over 125 and so on. So it will get there the same way. Other questions on that one? Anything? All right, so hold on, I see somebody's asking me about 8.78a. Okay, so I see. So for 8a, I see what you're asking. So let me just go to Wolfram Alpha. I mean, I can go to all sorts of places. I have Maple on this computer. I can do all sorts of crazy things. A Maple is more powerful than what you guys are going to find online. But so if I want to integrate, let's see, y squared plus a squared to the negative 5/2 dy. If I say dy, I wonder if it'll take it, or if it wants me to say with respect to y. I bet you it'll take dy. Ta-da! There you go. So it'll give it to you. Just write it. So no biggie. There is that's the one that's assuming a. I'm trying to look at the difference there, because this part's assuming that a and y are positive. Well, we don't know that y is positive. We know that a is positive. So I don't think it'll make any difference, really, to be perfectly honest. It's trying to get you to avoid negatives in case of imaginary number system answers and stuff like that. But I wouldn't worry about it too much. I don't think that the a is positive really is that big of a deal for that particular problem. So just plug it in a computer. Ain't no thing, right? I know you want the whole test to be like that, but it will not be. But you will, honestly, Calc 3, in Calc 3, every test I do, you have a computer. You're using your computer to do stuff. And same with my husband in DefeatQ, because my husband's a DefeatQ instructor. So, you know, students have computers through the whole exam. You know, you're using your computers to do stuff. So this chapter is kind of the end of, well, it's not the end because we'll do a little bit more of it, but it's one of the last gasps of by hand integration, right? And from that point on, we do a lot less with it in Calc 3 especially. Right. Calc 3, I'll do a lot of by hand stuff just because it's easy. You'll see when you get to Calc 3. But if it's hard, we just make computers do it. We don't do any of this crap by hand. All right, so 8-7, number 9B, I'm seeing people asking. Hello, Lindsay, how's it going? All right, 9B. 9B actually has some options. Which one did you want to try, Lindsay? Have you tried a formula and it couldn't get it to work? Or do you see one that might be useful? I think that's the hardest part about these stupid problems is figuring out which one of these stupid things is the one you want. But 9B, you have two big options, really. Oh, sorry, my P's are popping. I apologize. Let's see if I can get them on the same screen. Nope, that's too far. Hold on. Oh my God. Well, I saw two options, but there may be more. Whoop. Oh my God. Microsoft Word is driving me insane. So I apologize. Seriously. I don't know if you guys can see that it's just dragging and freaking out every time I want to do something. It's so annoying. There are two options on the screen right now. Yes, Daniel, that's one of them. 16 is one of them. And if you're going to make 16, actually 16 works beautifully because 16 automatically assumes that it's a quadratic in the denominator. It's a little weird. I got these from books, but A, B, and C are kind of the opposite of what you're normally used to. You're used to A being the one in front of the U squared, B being the linear, and C being the constant. But the textbook I got this from reversed them. There are reasons for doing that I don't want to get into. It has to do with formula building and junk like that. But it's kind of interesting to me that they did that. So there you have it, right? Interestingly enough, right? Yes, that's the other one, Shayna. That's it. Yeah, 16 and 26. Either one of them will work. To make 26 work, though, if you look at Shayna's idea of 26, because it's a good one. If you're going to make 26 work, sorry, I'm fighting. I'm going to have to check my stupid recycling box and find my stupid sheet. Right there it is. So 26. All right. To make that one work, you're going to have to do something first. It's 3 words. I feel like I'm playing charades. Yes, exactly, Lindsay. You'd have to complete the square, right? So if you want to use that one, it's cool. You got to complete the square. And if you want to use 16, 16 requires no special work. The weird thing about 16 is the order is not what you're used to. Oh my God. Sorry, I'm out of my screen. So if the order there for A, B, and C is not what you're quite used to. So you'd have to make A equal to 26 for us, right? And B is equal to 2, and C is equal to 1. Is that better, Lindsay, or do you want me to go through it? Waiting for Lindsay. He's good? Okay, cool. I mean, if you're worried about completing the square, guys, if like that just makes you, then just do 16, right? 16 will work.
Doesn't matter which one we use for 16.
It does. You have to choose the right one. So you want B squared to be less than 4AC. So if B squared, here, A was 26, B was 2, and C was 1, right? It's the opposite order of what you guys are used to. You need B squared to be 4, and you need 4AC to be 4 times 1 times 26, which is what? 80 plus another 24, so 104. Okay, so b squared is less than 104, which means it'll tell you which one it was. Because the top one is when b squared is less than 4ac, and the bottom one is for when b squared is greater than 4ac. Good question. See the little curly braces in there? Right, so you want to use whichever one is appropriate, which in this case would be the top one. Because for us, b squared is less than 4ac. You can't have b squared equal to 4ac. That's why if you look at the forms thing, it says forms involving blah, 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 and b squared cannot be 4ac, because then neither one of these formulas would work. It would actually be a different thing entirely. Is that good, Daniel?
Yep.
Cool. And then Amna's asking about 9a. I don't have it in front of me. Oh my God. Hold on. 9a. Oh my God, my stupid Microsoft Word is being super annoying. 9a. Oh, okay. X over 2 minus 3x. I bet you there's a couple of them, to be perfectly honest with you, Amna, that you could use. All right, let me see here. Oh, I can't scroll through. There we go. All right, so I think there would be a couple of them. I think there's one right on the first page, to be perfectly honest. So let's see if you can see it. It's on the screen right now. Oh my God. There we go. Sorry, I'm fighting it. I'm fighting Microsoft Word. Go away. Stupid Microsoft Word. All right, anybody see it? Which one's for 9a?
I'm just confused because on the first page, we have like a plus bu, but
Mm-hmm.
it's like 2 minus 3x.
Oop. Hold on. Sorry, math type just got weird on me. Go ahead. My screen got completely taken over for a second. Say it again, Amna.
Like on the first page, as it says like a plus bu.
Sure.
But on 9a, we have 2 minus 3x. So
Yep.
I don't know if that's going to work because it's a minus.
Can't b be a negative number?
Oh, yeah.
Yeah, it has no comment about the constants. The constants can be any number, and so if it's negative, then that would be minus, right?
Right.
Yeah. So which formula are you using? I can hear it.
Number 3.
Mm-hmm. Totes, right? When the sign matters, it'll tell you, right? So if you notice, these all say a plus bu, but that part isn't really relevant. The b could be a negative. If b could not be negative, I would have told you, right? So it would say up there. So like, for example, in these ones, a has to be positive. No other way. See it? And that's why the plus and minus matters so much for these ones. That and everything's squared, so that turns it positive, right? But for these ones with a plus bu, a and b could both be negative. One of them could be negative, either one. So don't be freaked out by the minus in there. That's a good question, right? So good point to raise. So don't worry about the signs. I recognize even though I write plus everywhere, it could just as easily be minus, right? And by the way, if it was a minus b, that would make this front number right there with the bu, that would be negative, right, for you, because you'll have b, I think b for you is negative, looking at it, -3. So you'll have -3 quantity squared, right, which will turn it positive, and then you'll have -3 times, and u for us is just x, right, because our u is really easy. They put u in because, of course, you could do it for sine of x. It can be all sorts of things. You could do this problem for sine of x over 2 plus 5 sine of x, right, where u is sine of x. I mean, that's possible, amazingly enough. And then you'd have to have your du in there, so you'd have to have a cosine floating around, but it's possible. Is that good, Amna? Is that better?
It's a lot better.
Good. No worries. So good point to raise. I didn't even think of it. So the ones where the sign matters, I tell you, like up in the bold part, I'll say like, A must be positive, right? Or, B is actually, for these ones, it's always A. And then there was that one where it was like B squared cannot be 4AC. Like I'll tell you those specific things. And other than that, I know all bets are off, with the exception probably of trig functions, because trig functions have domains that everybody just knows. Like you cannot take, I don't know, the tangent of, what is it? Tangent of 0? Sine over, no, it's the tangent of pi over 2. Tangent of pi over 2 is infinity, right? It's a vertical asymptote, stuff like that. Like that stuff still holds. Everybody better for 8-7? Any more 8-7? The hard part about 8-7 is just finding the freaking formula on the stupid table. That's the, in my opinion, the hard part. Be like, because you're searching through all these pages of formulas, trying to find the one that'll fit. But after that, it should be pretty just plug in. You might have to do 2 formulas. That's the other thing. You might have to do like 2 different ones or a repetition of the same one, stuff like that. Anything else for 8-7? Nothing? Any of my math lab questions out there just hanging? Nothing? Oh, 10A for, oh, okay. So I'll pose it to you guys. See if you guys can find it. We'll hunt for it. I almost ripped my page. Hold on. All right, so there's 10. So this one to me is going to need a U sub. When I'm looking at that, I'm thinking there's no form that involves like natural log inside a square root. Like that's not one of the basic forms. So I'm thinking I'm going to have to use U. You're going to have to use U. U would be equal to, all right, figure it out. What's U equal to?
Natural log of x.
You got it, Emma. Yeah. U is the natural log of x because du would then be 1 over x. And we'll get this bit taken care of. Like that. So then it's really the integral of the square root of u squared plus 4 du. And I think that one may be more obvious to you. It's in there somewhere. There's a formula for it. My watch is yelling at me that I've been sitting too long. It's saying I should stand up. I'm busy teaching watch. It's one of those smart watches. It nags me when it thinks I haven't been active enough. All right, did you guys figure it out? Hold on, I can't see the chat window. Chat window, where are you? There you are. Oh my God, seriously, chat window. There we go. Boom. Yeah, is it number 29? I think so. I think you're right. Let me grab the thingy. Of course, my screen will go blank. Of course it will. It's just typical of my computer right now. All right, so actually I shut it down the other day because it was being so bad in class, and I'm like, all right, it needs to shut down. So it's been better since then. Oh yeah, look right there. Shayna's right on. You guys see it? It's 29. Good call, Shayna. I mean, it's a lot of substituting. Like, I think it helps to like write down, okay, A is 2. Okay, so and like fill in the formula. Start with U first and then go back and put in what U was, which was natural log of x. Everybody good? I'm assuming everybody's writing, filling stuff out. Thank you, Mirabelle. I appreciate that. Actually, Mirabelle just texted me. Apparently, I've got a setting wrong. I might as well fix it while you guys are hanging out. Which one was it? Oh, 8-7. I gotta check my settings here. Apparently, I've screwed something up. So it should be due tonight. Everybody finishing 8-7, kind of writing down some stuff. Let's see, due date. I don't know why that's even on. Oh, it's not. That's why. All right, so this should be due tonight. Right? Isn't that tonight? Oh, come on. June 29th at 11:59 p.m. That's tonight, right? Because that's the one that's due tonight. All right. Hopefully this will work. Look at all those arrows. You see all those settings? God, there's so many settings in this here thing. It's just crazy. Okay. So that should be all set. Now I wonder about 4-7. Did I do it right there? Now I'm curious. Oh my God, seriously, come on. All right, meanwhile, you guys are looking at 4-7, because I assume that's the next thing, to find out what questions you've got there. L'Hopital's rule? Anyone? No, that one's all right. No, it's not. Close the quiz June 10th. Wait, what? That doesn't, today's the 20, wait, what? Hold on, that should close tonight, right? Am I going insane? Am I in the wrong side? No, that's 4-7. Okay, no idea what's going on there, but that's fine. All right, so hopefully everything's gonna work and we're good. Good God. All right, so 4-7. I see that, Maribel. All right, so stupid thing. All right, 4-7 number. Oh, I gotta put this way. Was it number 9 and 6 and 11? Okay, so let's see what we got here. Ooh, 6 is multiple choice. Those are always fun. Hold on. If the limit as x approaches a, oh, good grief, is equal to the limit as x approaches b, oh. Okay, so I guess my question to you is, what do you think for 6? So as x approaches a for f of x, it's going to infinity. As x approaches a from g of x, it's going to infinity. But then what happens if you subtract them? I see your question, Shane. I'll help you. It has to do with standard math teacher speak. But everybody else for 6, what are you thinking? Infinity? Think about what this would be. This would be infinity minus infinity. Do you know what infinity minus infinity is? Hold on. Let me get the notes out. See what heading it's falling under? Yes, Connor, exactly. We don't know. It depends on what f and g are. If f is infinitely larger than g, then it might be infinity. It might be 3. It could be 0. It could be negative. I mean, there could be so many different answers because it's indeterminate. It could be anything. So that's why the answer is C for that one, because it depends. It just depends on what they are. Is that making sense? Right? So for 6, basically, it's going to end up being an infinity minus infinity. Infinity minus infinity is indeterminate. We don't know what it is. Cool, good. Everybody okay? Good with that one. And then I see 9. 9, the trick with 9, what makes them different is that this one is the quotient of the numerator and the denominator, and this is the quotient of the denominator and the numerator. So the top one, A, would be you take the limit. Here, I'm gonna write it. Limit as of f prime of x over g prime of x, that's A. And D is you take the limit of g prime of x over f prime of x. It has to do with order in the English language. Whichever one we put first, when we say quotient, whichever one we put first is the numerator. So you'd be taking the denominator's derivative and putting it in the numerator. And then you take the numerator's derivative and put it in the denominator. Does that make sense, Shana? So that's kind of standard math speak. So when you say quotient of blah and yada yada, blah is always the numerator, yada yada is always the denominator. Whichever one's first in the sentence, that will be the numerator. Yeah, it's weird. So by the way, everybody, so looking at that one, what would be your answer then? Exactly, Shana. Yeah. Cool. Everybody good with that one? Yeah, that one's weird because you'd think both A and D are correct, but D is not right. D is not what we do, right? So it has to do with that one becomes the top. Cool. All right, so that was that was 9. That was 9, and then I saw another one on the chat window somewhere. 11. All right, so let me find 11. Okay. So for 11, looks like it's going to be some kind of weird formula. Not formula, form is what I'm talking to myself. All right, so for 8, it's 4.7. 4.7, number 11. Okay, so we're taking the limit as x goes to 0 on the negative side of 2, 1 over x minus cotangent of x. And I'm almost positive this is infinity minus infinity. Let's check it. Since none of us are super comfortable with cotangent of x, it's just kind of like a regular thing. All right, so let me make it so that I can call it f of x. I don't really care. F of x equals 1 over x, looks like this, minus cotangent of x. Okay, so I'm approaching 0 from the negative side. Looks like it isn't even in, oh, it's because you can't, got it. I get it. So analytically, you can't put it in there. Got it. If you do, it'll be undefined. Oh, and there's a 2 out in front. All right, so, but I think looking at the graph, we can all see what this is going to be. Yes, everybody sees what the answer is going to be? We're going to have to prove it. Beep. All right. Okay, so just looking at cotangent of x, just so I can get it. Yeah, that's what I thought. So cotangent of x is infinity, and 1 over x also infinity as we approach 0 from, what is it, the negative side? Approaching from the left. So they're both negative infinity, whatever, right? It doesn't really make any difference because it's just going to be, because for infinity minus infinity, remember, it doesn't, how do I put this? If it's negative infinity minus a negative infinity, then it's still indeterminate, right? We don't know what this is going to be, although we actually do when you look at the graph, but so be it. Okay, so I would change this form. I've started off, when I did this, I went, oops, sorry, you can't see what I'm writing. There it is. So I made it go like this. And then I said, hey, that's 1 over x minus, and then I rewrote this as cosine of x over sine of x. Because quite frankly, I'm going to try to get them together. I want to turn it into a fraction. I don't want it to be subtraction anymore. I'm trying to get 0 over 0 so I can use L'Hopital's rule, right? So this currently, the form is infinity minus infinity. So if you look at this one, this is infinity minus infinity. This is still infinity minus infinity, right? So I cannot use L'Hopital's rule yet. This is 2 limit as x goes to 0. And then I'm going to multiply this one by sine and this one by x. So this is sine of x minus x cosine of x all over x sine of x, like that. Cool. We good? Everybody okay? To do that, I mean, it's basic, you know, I multiplied this one by sine over sine and this one by x over x. That's what I'm doing, right? I'm trying to get them to have a common denominator, right? Now, why did I do that? Well, because then I think this becomes, let me think, this is 0, sine of 0 is 0. So that's 0 down here. And then the numerator, that is sine of 0 is 0 minus 0 times 1. So that's 0 over 0. Yay. So then we can use L'Hopital's rule. So then I write equals L'Hopital's rule. And it's 2 limit as x goes to 0. Now the thing is that for L'Hopital's rule, I'm going to need product rule, right? Because the derivative of x sine of x and the derivative of x cosine of x both require product rule because there's multiplication. So the derivative of sine is cosine minus the derivative of x is 1. Leave the cosine of x alone. Okay, so then it's like minus this, right? So it's minus this plus, and then the derivative, leave the x alone, derivative of cosine is negative sine, like that. And then down here, it's going to be 1 sine of x, 1 sine of x, derivative of x is 1, leave the sine of x alone, plus x cosine of x, like that. And then I'm just going to clean that up a little bit. The weird part is this part, because when you take the derivative of cosine, it's negative sine, but then there's a minus in front of it anyway. So it's ended up being minus minus, which is plus, right? And then these two are gone because cosine and cosine disappear, go off on their merry way. And it leaves me x sine of x over sine of x plus x cosine of x, which I believe is still 0 over 0. Right? Because if I plug in 0 here, that's 0, that's 0, and that's 0. So this is still 0 over 0, and I don't know what it is. So I have to do another one, which is 2 limit x goes to 0, negative. All right, so this would be sine of x plus x cosine of x over derivative of sine is cosine. And then plus, and then it's the whole 1 cosine x minus x sine x, that part again. I think we're better off now. Yeah, we are. We can put 0 in, because if I put 0 in, the denominator's not 0 anymore. This part's 0. So if we put in 0, we'll get 2 times sine of 0 is 0 plus 0 times 1 over 1 plus 1 minus 0 times 0. So it ends up being 2 times 0 over 2, which is 0. So we had to do 2 applications of L'Hopital's rule on that one. I'm not telling you that's the only way you could have done it. I mean, cotangent leaves you, you know, there are probably some identities or something else that we could use. But I figured cotangent is cosine over sine, and I want to turn it into division to make L'Hopital's rule work. So that's why I did that the way that I did. Better? I don't know who asked that one. Is that better? Thank you. Oh, I should have waited for a thumbs up on the last one. Everybody good on this one? Oh, sorry. And notice, by the way, it matches the graph, right? And that's what we were seeing in the graph. The trick is that it said we had to use L'Hopital's rule. So thank you for the thumbs up. I thought I saw that. Was it Jessica, I think? Or was it Lindsay? Somebody, my screen is all weird. Everybody good? I'll wait for you to finish writing. Thumbs up me when you're done. Oh, whoa, fuck. I got 5 thumbs up all at once. All right, we're good then. Everybody's okay. All right, so that was 11. Anything else? Anything else in 4-7? Nothing? Oop, 10C. 10C. Hold on. I got to back up to 10C. Oh, 10C's got more, what do you call them? Trigonometry. Trig is always such a pain. I mean, I like it, but you know, I get the students, it's not students' favorite thing to do. I think with 10C, you can rewrite pretty easily and make it turn into something nicer though. So if we're good with 11, I got a lot of thumbs up, so I'm assuming we're cool. All right, so 4.7, 10C. Okay, so this is the limit as x goes to pi of x minus pi times cosecant of x, like that. All right, just checking my form here. Oh, cosecant of x. It's not something you guys are like super comfortable with. I know where it's going, but let me just show you. Okay, so cosecant of x, I'm approaching pi from, is it from a side? Oh, it's just, oh, that's just wrong. I should be approaching from a, that's not good. Well, we'll just say from approaching from the negative. Sorry about that. I should have a little negative. I'll fix that for next time. So I'm going to say I'm approaching from the negative side. So I'll put a little here, so you guys can see. I'll put a little negative sign next to that. I'll fix that in the worksheet. So because you really shouldn't be doing, if it's split like this, which in the way that, oh, I lost somebody. Uh-oh, they got really offended by that one. Hopefully it wasn't the person that asked about this question. That would be bad. Okay. Oh my God, I think, no, it wasn't. It wasn't Jessica. All right. Okay. So we're approaching pi from the left and the right. We should do from the left. That way we're going this way. So it's going to infinity. I mean, I can do the right. It doesn't matter if it's negative. What the problem is that I shouldn't be doing either side because there is no limit if you're coming in from either side. It just doesn't even exist. So that's a little strange. So sorry about that. All right, so this is 0 times infinity because this part would be 0 and then this is infinity as you're seeing from the graph, right? So if it's 0 times infinity, then I need to change it because I got to get it into 0 over 0 form or infinity over infinity form. Does anybody remember what cosecant is? It's a very basic identity for cosecant. It's kind of how we define it. Yes, Connor, exactly. 1 over sine. So you go, hey, that's the limit as x goes to pi. Again, put a little negative sign there. Sorry about that. Of x minus pi times 1 over sine of x. The sine of pi is 0. So that turns this into 0 over 0. Ta-da! We can use L'Hopital's rule, right? And right there, we're set. Right, because this will be by L'Hopital's rule, the limit as x goes to pi from the negative, and then take the derivative of each part. And then you're kind of done. Like you'll be able to substitute after that step and be done. Is that better, Connor? I didn't finish it, but you okay? Derivative of x minus pi is 1. Derivative of sine is cosine. Plug in. Bing, bang, boom. Cool. Anything else? What about 12? Do people need to see 12? I'm worried about 12. 12 is the one that involves logarithms. You guys want to see it? Yeah, I think you should. I mean, if I were you, I'd be like, yes, please do the hardest problem in the worksheet for me. Thank you. That'd be really nice. All right, so that's all right. That's why we're here. We're here to learn. So if I help you guys now, then you'll do better. That's my hope. All right, so for 12, you're taking the limit. What are we doing? X goes to 0 from the plus side of x to the 7x. Okay. 0 to the 0 is an indeterminate form, right? So this is 0 to the 0. It's one of the indeterminate forms. Because, and I always get students confused on this, who wins out, right? So when you're in, because students see 0 to 0, it should just be 0. No, the answer to this problem is not 0, as a matter of fact. Oh, it was CJ that we lost. Hey, CJ, having internet problems? Or did my answer to a question just offend you? All right, so 0 to the 0. Okay, think about what you learned as a kid. You learned 0 to any power is 0. But then you learned anything to the 0 power is 1. Who wins? And the answer is neither one of them. Sometimes it could be 0. Sometimes it could be infinity. Sometimes it could be 3. You know, it can be all sorts of things. So 0 to the 0 is indeterminate. So the way we handle all of the power ones is we say, hey, let's call that L for limits. And then you take the natural log of L equals the limit as x goes to 0 from the plus side of the natural log of x to the 7x. But power properties of logarithms say that when you have a logarithm of something to a power, you can bring the power down in front. And so therefore, the natural log of L is equal to the limit as x goes to 0 of 7x times the natural log of x. Now we're still not set because that is now, we turned our form from 0 to the 0 to 0 times infinity. Negative infinity at that, but still, this is 0 times infinity. Think about the natural log curve, right? As you go towards the y-axis, it's going to infinity, right? Negative infinity. So that's not good, right? That's indeterminate still, but we're closer to what we want, right? But we want to turn it into 0 over 0 or infinity over infinity or something like that. And so we take the trick that we keep using all through this section. I'll just pull the 7 out because 7's not relevant. So limit as x goes to 0, natural log of x over 1 over x. Now it's infinity over infinity, and I can use L'Hopital's rule. Cool. So now I can say natural log of L, L'Hopital's rule. I'm going to stop writing natural log of L. We don't need it all the time. 7, limit x goes to 0 from the plus side. The derivative of natural log of x is 1 over x. The derivative of this would be x to the negative 2, right? Oh, negative x to the negative 2, sorry. So it's x to the negative 1, right? And so rearranging that, just think about that for a second. Right? This would be 7 times the limit as x goes to 0 of negative x. And I think y'all can handle it at that point. All right, so you're going to find a number. It's 0, but that's not the answer. That's the natural log of the answer. So L would be equal to, exactly, CJ. Look at you, having internet problems and still coming in with the answers. It's lovely, right? It's 1, it's e to the 0. There you go. Cool. Everybody better for 4-7? I was just waiting for you guys to write. Good. Okay. Well, awesome. Hooray. So we have an hour left. What do you guys want to do? Well, not an hour, but like 50 minutes. So we have some options available to us. So 1, I assumed you guys are finishing up your 4-7 and 8. What is it? 4-7 and 8-7. Those ones that are due tonight. You could work on the My Math Lab, or I could lecture over 8 and 9, but that's not due tonight. So me personally, I'm wondering if we should just let class go early today and you guys can work on the stuff that's due tonight. Yes, no. Good idea, bad idea. It's good. Okay. All right, cool. That's fine. That's fine. Don't say I don't give you nothing. Don't be like, class isn't valuable. I help you guys with all sorts of worksheet questions. All right, so cool. If you got, I'm just going to be working at my computer. So if you, oh, I see. I'll post that recording, CJ. Sorry, your internet's being weird. I'll do it right now because I'm not going anywhere right now. We actually took the dogs to daycare so we could work today, so I'm not going anyplace. Other than I really need to go for some exercise. I'll go for a walk later. Other than that, we're set. I won't let you out early all the time, but it's okay for today. And then 8, 9. Make sure you watch those 9 videos for Wednesday and start working on that worksheet because it's going to be, there's a lot of work to do in that one. And then you guys can start working on your sample exams. I might not help you directly with them, but I can nudge you. The 8-9 worksheet is 8 pages, 8. So, and that's because I do a lot of one problem, whole page, one problem, whole page, but still, if I expect you to use a whole page to do it, you guys better start on that tomorrow, okay? All set? So work on your 8-9 after you get your stuff in, okay? If you got questions, just hang around and stay after, and we'll go there. I'll stop sharing. Just hang out if you still got questions. Hey, Maribel, stay after for a second. I just want to make sure I get what you're asking me. So